engines for the most part. So I worked at Mozilla for a few years, like 6 years or so, kind of mainly on the graphics team, working on the rendering engine and WebKit. Worked at Igalia on WebKit, kind of in a similar kind of area for the Linux backend. And I think that's given me kind of a decent insight into how to write performant web applications, which is what I'm going to try and distill in this quick 5 to 10 minute talk. Okay, so what to avoid in web development was the title that I was given to do a talk on, and that's a pretty broad scope, so I think it'd be good to kind of identify some goals. So primarily we want a smooth frame rate, so that's kind of being able to update at 60 hertz, 60 times a second, or whatever the refresh rate of the monitor happens to be. We want a fast user response, which means visual feedback for an action needs to happen in a reasonable time frame. So, I mean, just for the sake of putting a number on it, let's say 50 milliseconds, you want to click something, within 50 milliseconds, something has to happen. We want a consistent response, so ideally there shouldn't be situations where suddenly the frame rate tanks or suddenly the response rate tanks. And we want visual coherency as well, which means we shouldn't be displaying partially rendered content, and UI shouldn't display progressively. So you shouldn't see, your dialogue loads up and then your style loads up a second later or something. Like, it really should just be appearing immediately. And then secondarily, if possible, we want to use as little CPU as possible because, climate change. And we want to use as little memory as possible because, we want to be a good citizen and share this device with other things as well. So let's tackle that first one. Maintaining a smooth frame rate. We need to consider like our browser and web application as just a monolithic whole. That's how you kind of... these are like performance issues. It doesn't really work if you kind of don't consider it as one big thing. Like if you just consider your web application separately from the browser, you don't have the full picture. So we have to kind of like, what are we asking the browser to do? That's what we've got to establish. And then once we have established that, we need to consider things that are slow and outside of our direct influence. So in this case, for web applications, page layout is slow. Page rendering is slow, and garbage collection is slow. And when I say slow, I mean these things take time, they're not instantaneous. And that gives us some targets. We want to structure our application to minimize the amount of page layout, we want to minimize the amount of page rendering, and minimize the amount of garbage collection. So our kind of next goal was a fast user response. So we set a limit, I set this limit of 50 milliseconds. You can put any number there, it doesn't really matter, but I'd say any number below 100 milliseconds. And the guiding question is, what can you feasibly achieve in 50 milliseconds? And the short and vague answer is not that much. With a large application, it's difficult to know at all times how much work is already being done beyond the added work that we need to perform based on a user action. So this means that we need to go in with the mindset that any amount of work is too much work. We should be prepared at any point to show visual confirmation to the user that we've received an action, and work required to service that action should be split into tasks that can be performed both asynchronously and progressively. So we covered frame rate and response, and this is quite related to that, achieving consistent user response. But I think dealing with consistency is a lot less intuitive than with those first two things. So to achieve consistent response, we need to avoid causing the browser to lock up for any significant amount of time. And this is one of those things that crosses over into things that aren't under our direct influence. But let's say, consider that if your screen refresh is 60 hertz and the user is scrolling, you have 16.6 milliseconds at most to do everything you need to do. If you take longer than that, your scrolling is no longer smooth. So let's say if a deferred task takes an uninterrupted 8 milliseconds, we've chopped that budget in half. Suddenly we don't have 16 milliseconds anymore, we've only got 8 left. And it could be worse than that. So any work that's a deferred background task must be either tiny or must be something that be completed progressively. So you should be split up, completed over time. And we also want to avoid causing garbage collection, and that's not so simple, so I'm going to come back to it later. Maintaining visual coherency. This is a more nebulous point than the others, but it ties into them. And by visual coherency, I mean both not displaying partially rendered content and also visual feedback being visually consistent over time. So, for example, when we scroll, we should expose new content. Scrolling should always expose new content. It shouldn't expose blank or partially rendered content. And if that must happen, we need to communicate to the user in some way why that is happening, and we need to do that communication in a consistent way. A further example, like if the user presses a button that needs to display a dialogue, it should always display that full dialogue. You should never see temporarily unstyled content. There shouldn't be some kind of pause that is an indeterminate variable amount of time. And that's kind of the kind of technical aspects of it, but like there are other kind of things about this as well that kind of more like feel things, like animations should be consistent. You know, if a dialogue fades in, all dialogue should probably fade in. You shouldn't have one scaling on, or one popping in, or one immediately appearing. We should be consistent about these things. So far I've spoken quite in general terms, but what concrete real-world advice can I give? So this is a list of things that I think, apparently when I wrote this, that all developers of large web applications should be thinking. So avoid touching the DOM. Even reading the DOM can be expensive, and that's the unintuitive one, I would say. Like most people, they understand that making DOM changes can be expensive, but just reading properties from the DOM can be expensive. When you read a property from the DOM, you're forcing the browser to make that property available. And there's all sorts of cleverness that happens behind the scenes to do with like asynchronous layout, progressive layout, where when you make a DOM change, that's not the end of it. The browser carries on over time. But if you then immediately request some piece of information that requires that to be up to date, you're forcing that to happen then and there. And that can cause more rendering than would otherwise be the case if you kind of could delay that change or whatever. Second kind of piece of advice, we should be batching DOM manipulation. That's a similar kind of point. Like if you can group all of your DOM manipulation in one place, it reduces the likelihood that a read will cause extra work. And I said I'd touch on garbage collection again. This is where I'm going to touch on it. If we constantly allocate and deallocate objects, we're more likely to trigger a lengthy GC period. So best thing to do when possible is to reuse objects. You should have object pools rather than just letting go of an object and thinking the browser's going to take care of it. Better to return it to a pool and reuse it if possible. So you want to naturally extend the lifetime of an object. And a whole second page of real-world advice. We've mostly talked about things that are slow in the browser, but there are things that are fast as well, namely CSS animations and transitions of transform properties. Those are fast. Changing the position of an element will cause layout to happen if you change the top or left of an element, or you change its size. But changing its transform is fast and usually GPU accelerated as well. So that's something you can kind of guarantee that, like if you touch a transform, you will still have to, it will cause restyling and like an amount of interpretation, but it won't necessarily cause a re-layout, it will just cause a re-render. And that's one reason also that I'm just going to take a quick dig at jQuery. That often shows up like frequently when you're investigating poor performance, because there are like several built-in functions in jQuery that manually animate like display properties, which is just don't know. Like, it's a terrible thing to do. Like you should there are certain features of the browser that were designed for these kind of things. So like CSS animations and transitions mean that you don't have to have a repeating callback that keeps returning into your JavaScript code and spinning up the interpreter and so on. It's like you can just leave that to the browser and it will do that all in native code, which is nice and fast. When you do your own animation, we should be using request animation frame. This is probably something everyone knows at this point, but you shouldn't be doing animation using set timeout, which is something else that jQuery does. So request animation frame will run a callback once before triggering a render of a new frame, and it's designed exactly for programmatic animation. So it'll be in sync with the monitor refresh as well, and it would be called at a convenient time for the browser, which is the other important thing. Like a set timeout doesn't necessarily have that implication. And my last point, which I'm really hoping I can scroll to because I can't remember offhand. Yes, I can. My last point was about picking what to optimize, and it's easy to kind of get stuck in the trap of spending all of your time optimizing something that doesn't matter. So optimization efforts should always be guided by profiling when possible. The biggest enemy of good performance isn't necessarily unoptimized code, it's overcomplicated and poorly structured code. And that's it. So, thank you.